Hello, good morning. I'm discussing about kinetic properties of colloids. First of all, diffusion. It is the spontaneous process where the solute molecules move from a region of high concentration to the concentration until the system becomes uniform. It is the process the molecules move from a region of high concentration to the low concentration until the system becomes a uniform. Diffusion is the movement, anything, for example, atoms, ions, molecules, energy, generally from a region of high concentration to the lower concentration. See in this figure, this is the higher concentration. The molecules are moving to a lower concentration. The rate of diffusion is expressed by the Fick's first law. dq amount of material diffuse, d diffuse and coefficient. This over dx concentration gradient is area. For particles or large molecules in a viscous fluid, usually a liquid solution, this Stokes-Einstein equation can be applied. Diffusion coefficient D equal kT over 6 pi mu r. Where k is the Boltzmann constant and mu is the solvent viscosity and r is the radius of the diffusing particle. Osmotic pressure is defined as the minimum pressure applied to a solution to stop the flow of solvent molecules through a semipermeable membrane. The osmotic pressure of a solution is proportional to the molar concentration of the solute particles in the solution. Osmotic pressure depends on number of particles in dispersion. In case of associated colloids, each aggregate acts as one particle, so osmotic pressure is low. It is used to calculate the molecular weight of solids. Osmotic pressure P equal to CRT over M. P osmotic pressure, C concentration gram per liter, M molecular weight, R gas constant, T absolute temperature in Kelvin. Sedimentation, the process of settling down heavier insoluble solid particle at the bottom of the container due to the gravity is called sedimentation. The heavier insoluble solid particles that settle down at the bottom of the container are called sediments, and it is used to separate the solid liquid mixture. In colloidal dispersion, browning movement tends to act this sedimentation, so ultracentrifuge is used for studying the sedimentation in colloidal dispersion. In ultracentrifuge, particles settle according to the molecular weight, molecular equal to RTS over D 1 minus mu naught. R gas constant, T absolute temperature, B partial specific volume, mu or rho, density of solvent, yes, sedimentation coefficient at 20 degrees Celsius, D diffusion coefficient at 20 degrees Celsius. Viscosity, the resistance are to flow liquid. Viscosity, the resistance to flow liquid is called viscosity. The viscosity of colloid particle depends upon the shape, size, molecular weight, interaction between the particles and dispersion medium. A quantitative expression for flow of the dispersion system is the spherical particles. This is the formula, the viscosity of dispersion, viscosity of medium, volume fraction of colloidal particles. Centrifuge is a device for separating the particles from a solution according to their size, shape, density, viscosity of the medium, and rotor speed. This is the centrifuge. Solvent, small size particle, medium size particle, large size particle. This is the separation. Ultracentrifuge, it is important tool in biochemical research, which through rapid spinning imposes high centrifugal forces on suspended particles or even molecules in the solution and cause separation of such matter on the basis of differential weight. Or the ultracentrifuge is the sophisticated and advanced centrifuge that operates at an extremely high speed and separates smaller molecules that cannot be separated from the traditional centrifuge. The speed of the rotor in ultracentrifuge can range from 6,000 RPM to 15,000 RPM. Ultracentrifuges are mostly operated in more facilitated laboratories to perform the more advanced operation. These are larger in size and can operate samples either in batch or as a continuous flow system. Most ultracentrifuges are refrigerated in order to control the heat that might be generated due to excessive speed. Examples: red cells separated from plasma of blood, nuclei from the mitochondria in cell homogenates, one protein from another in complex mixture, and also isolation of macromolecules such as DNA, RNA, lipids, etc. It is the rotational speed up to 15,000 RPM. It is creating a centrifugal force. Uh, in analytical centrifugation, the aim of analytical centrifugation is used to study the molecular interaction between the macromolecules or analyze the properties of sedimenting particles such as the advanced molecular weight. Preparative centrifugation, the aim of preparative centrifugation is to isolate, purify specific particles such as submolecular organisms. Functions of analytical centrifugation use small samples less than 1 ml, build the optical system to analyze the progress of molecules during the centrifugation, uses relatively pure samples used to precisely determine sedimentation coefficient of molecular and molecular weight of molecules. A Beckman model is example of centrifugation used for this purpose. Functions of preparative ultracentrifuges, larger sample size can be used, no optical read out collect facts and analyze them after drawn. Less pure samples can be used to estimate sedimentation coefficient and molecular weight, generally used to separate organelles in molecules. Most of centrifugal work done using the preparative ultracentrifuge. It is the all about uh, kinetic properties of colloids. Thanks for watching. Thank you for the patience. That's now. Bye bye. See you.